Hello guys, so it's been a while since nakapag-upload ako ng video. So alam natin yung mga nangyayari ngayon sa paligid natin and so sa Bureau of Fire Protection kasi ako, so tuloy lang ang pasok namin sa trabaho. So naging busy din talaga. So anyway, so yung topic natin ngayon is hydrostatic force on plane surface. Okay, so kung meron tayo um, nakalubog na surface na plane or any, let's say, metal, gate, or any surface. Okay. Okay, so ito yun. Then, kung titingnan natin, so, from this point of view, so ito yung area. Okay. So, paano natin makakuha yung hydrostatic force, yung total hydrostatic force within a plane? Okay. So, alam natin na nagva-vary yung pressure natin from point A going down to point B. So, habang lumalalim tayo, so yung pressure natin, diba? Pressure is equal to unit weight, yung depth, gamma, and height. So, unit weight and yung depth natin. So, habang lumalaki yung depth, so lumalaki yung pressure. So, kung titingnan natin yung pressure diagram, so, meron tayong pressure at point A. Okay. So, habang malalim tayo, lumalaki din yung pressure natin sa papunta sa may point B. Okay, so hirap mag-drawing ng straight. Okay, papunta sa may point B. So, mas malaki yung pressure natin dito dahil mas malalim. So, hindi ganun ka-straightforward yung pag-compute. Unlike nung kung meron tayong, um, let's say, isang plane surface na naka-horizontal. Okay, so let's say naka-horizontal yan. Let's say that yan yung ating plane surface. So, yung depth niya from the liquid surface is constant. Then, kung kukunin natin yung pressure niya at any point, so we have a constant pressure. So, kung constant yung pressure natin, okay? So, kung constant yung pressure, so let's say ito yung pressure diagram, uniform. Then, uniform pressure, then solving for force. So, yung force natin is simply equal to pressure times area. Okay? So, pressure times area lang. And yung resultant or yung resultant ng pressure na yun, yung resultant force F, yung total force, will be acting dun sa centroid ng area. But in this case, okay, so napansin nga natin na yung pressure diagram natin is trapezoidal. So yung force F natin will be leaning towards dun sa mas malalim. Okay? So, let's derive paano natin makakuha yung total hydrostatic force and paano natin malolocate yung force F. Okay. So, erase ko lang muna to. Okay. So, consider natin tong differential area natin dito. So, meron tayong differential strip. Okay. Meron tayong, let's say, consider yung differential area. Then, within that area, pwede natin makuha yung differential, meron tayong differential pressure. Or meron tayong pressure dito. Then, we can solve for the differential. Actually, this should be differential force. Okay. Acting doon sa differential area. So, again, yung force F is equal to pressure times area. So, differential force is pressure times nung pressure at that location, okay, times ng ating differential area. Okay. So, paano natin makuha yung pressure? So, yung pressure is, di ba? Sabi nga natin kanina, pressure is yung unit weight times nung depth. So, from this point, meron tayong depth h. Okay, so yung h natin varies from this point na mababa tayo. So, variable yung h natin. So, pressure is unit weight times ng height times ng ating differential area. So, to get the total hydrostatic force, okay, so marami tayong strips. Okay, so yung total hydrostatic force F. So, integrate natin both sides. Then yung force F. So, pag na-integrate na yung differential force, so magiging total force na yan. Then, constant yung ating unit weight. So, labas natin to. Okay. Unit weight. Then, the integral of h times differential area. Okay. Pero, from this figure, so meron tayong parang triangle dito. Okay. From this point. Okay, so meron tayong triangle. Ito yung right angle natin. Ito yung angle theta. Then, sine of angle theta is equal to, opposite natin is yung variable h over nung ating y, which is also variable. So, h is y sine theta. Okay, so substitute natin dito. Solving for force F, that is unit weight, plus the integral of y sine theta, then yung h, times ng ating differential area. So, constant pa rin yung sine theta. Okay, so labas natin to. Unit weight, sine of the angle, then the integral of y dA. Okay, y times the differential area. Okay, so yung integral natin is, di ba, ano yan? Parang summation din yan. Summation ng napakaraming differential areas natin. So, kung titingnan natin, yung y dA, so kung meron tayong, sa pag-compute natin ng centroid of an area, so let's say ito yung shape natin. Okay. So, consider natin itong area 1, area 2. So, kung kukunin natin yung, let's say this is, so, gitna nito. So, let's say that is x1. So, mula dito sa reference hanggang sa gitna, that is x2. Then, yung centroid ng area natin, so, let's say somewhere dito. So, yung distance na yan is yung ating x bar. So, paano natin kinukuha yung centroid of an area? So, diba yung x bar times in total area is equal to x1 area 1 plus x2 area 2. So, kung marami pa yan, etc. etc. Okay. So, we can say na yung x bar times area is equal to summation ng mga distances natin, xi, ai. So, itong part na to is kung differential area yung pinag-uusapan natin, napakaraming differential area niyan, then we can say na yung ating x bar, okay, or in this case na lang, no, dito sa ano natin. Okay. So, with respect dito sa surface. Okay. So, yung y dA, so yung distance y natin is from surface din. So, nagbabari yung, variable yung y natin times yung area natin. So, we can say na yung yung integral nung y dA, which is yung summation, parang dito, which is yung summation, is equal to yung y bar times yung total area natin. Okay? So, pwede natin i-substitute to dito sa may integral sign. Then yung force F is equal to gamma sine theta muna. Then yung integral of dA So, para lang malinaw, is equal to y bar, then yung total area natin. Okay? So, balik natin ngayon to. So, kanina, this is h, naging y. So, ngayon, y bar to. So, from this figure pa rin, this is, hanggang dito sa point na to, this is y bar. Mula to sa liquid surface natin. Okay, so y bar. Then this is, papunta to sa taas. So, yun yung ating h bar. So, y bar sine theta is equal to h bar area. So, yun yung formula natin para sa hydrostatic force. So, yung unit weight times h bar, so that is simply yung pressure sa may center of gravity. Okay, so sabihin yung force F pala is kung ano yung pressure sa center of gravity or center of area, centroid, multiply mo lang ng area, then that is your force F. Okay, so paano naman yung location ng ating force F? Okay. So pwede tayong mag-moment of area. So from liquid surface pa rin. Okay. So parang ito ulit yung gagawin natin. Okay. So parang yan pa rin. So yung x bar ay location yung location ng area, but in this case yung force ang hinahanap natin. Then or kung meron naman tayong let's say meron tayong isang bar dito, isang beam. Then nilagyan mo ng mga forces, let's say F1, F2, F3. Then meron siya mga distances na x1, x2, and x3. Then kukunin natin yung ating resultant force. Let's say resultant force R. So para natin kinukuha yan, so meron yung distance na x bar. Okay. But in this case, sa figure natin, ang mga distances natin is y. Okay. So in force F, ang distance natin is yp or ycp, center of pressure. Okay. So this is cp, ycp. Okay. So from liquid surface, so we can say na, so based dito sa figure na to, yung force F multiplied by ycp, so that will be equal to yung differential force dF natin. So kasi kung meron tayong differential area dito, meron tayong differential force. Okay, then yung differential force natin is merong distance y, from the liquid surface. Okay, so F, yung force F times ycp is equal to, kunin natin integral nito, no? Integral of, ko yung y. So, yung differential force is equal to, kung babalikan natin dito, meron tayong differential force dito. Okay. Differential force is equal to, okay. So, yung unit weight, yung depth h, then yung ating differential area. Or pwede rin, kung di pa natin in-integrate to, differential force pa rin naman to. Okay, so pwedeng ito yung kunin natin. Okay. Okay, so again, in-integrate na kasi natin yung Okay, so para medyo nalito lang ako. So para hindi ako malito, okay. So in terms of, ano muna tayo, wala mo ng integral. So yung differential force is equal to yung pressure times ng differential area. Then multiply by distance y. So dito ko na lang ilagay yung y. So since meron tayong differential area dito, okay. So pwede natin ngayong integrate. Okay. So integrate natin itong isang side. Okay. Then YCP. Then yung force F kasi natin is, ito nakuha na natin, no? Gamma H bar A. Okay. So this is equal to integral of y. Yung pressure natin, paano natin nakuha yung pressure at this point? The depth y. So that is yung h. So yung pressure is unit weight times yung distance h. Okay, so again, ito yung distance na, ito yung location na kinoconsider natin with distance y from surface, liquid surface. Then, vertical distance naman natin or yung depth natin is h. So, gamma times h is yung pressure. Okay, so yun yung pressure natin times the differential area. But again, from this figure nga, so yung h natin is equal to y sine theta. So, i-apply natin ulit dito. So, divide muna natin to ng yung force na gamma h bar A. Okay. So, now we have the integral of, so unit weight is constant, labas ko ulit. Then, meron tayong y times yung h natin is y sine theta, differential area, all over unit weight h bar A. So, pwede natin i-cancel yung unit weight natin. So, continue natin yung derivation. So, YCP is equal to, so, ngayon, pwede na rin natin labas yung sine theta. So, ilabas ko na yung sine theta is equal to the integral of, so, dalawang y, so we have y squared, then yung ating differential area. Then, all over h bar A. Okay. So, kung titingnan natin, itong portion na to, okay, integral of y squared dA. Iba yan is moment of inertia, double moment of area. So that is equal to moment of inertia about the liquid surface kasi yung distance y natin is from the liquid surface. Okay? So over h bar A. Okay. So going back pa rin dito sa triangle, okay, sabi nga natin is h is y sine theta, then y is equal to h over sine theta. So kung babalikan natin to, h bar over sine theta, okay, although baliktad lang, no? Pero parang h bar over sine theta yan, then that will be equal to y bar. Okay, so yung distance y, inclined distance from the center of gravity. Okay, area, then yung moment of inertia about surface, so mas madali kasi kung yung moment of inertia na ginagamit natin is from the centroid. So yung mga meron tayong table, makikita na natin how to solve, yung mga may formula na how to solve for the moment of inertia. So hindi na natin i-derive yung mga yun kasi different, ano na yun, so different subject na yun na di-discuss. So by this time, dapat alam na natin or familiar na tayo doon. So gagamitin na lang natin if kailangan natin yung mga moment of inertia is yung, or are those tables na available na naman. Okay, so kung meron tayong moment of inertia, pero sa formula kasi natin, that is, so that is ano, no? Moment of inertia about the surface. So kung kailangan natin yung moment of inertia from the surface, paano natin siya makukuha kung meron tayong moment of inertia from the center of gravity? So, di ba, ito is ita-transfer natin papunta dun sa axis na kino-consider natin, which is yung liquid surface. Okay? Okay. So, yung moment of inertia about the centroid is ita-transfer natin dun sa liquid surface. So, to do that is, di ba, i-add lang natin yung area times nung distance squared. Okay? So, parang y squared dA pa rin. So, yung area, total area, then ano yung distance natin from the centroid? Diba, that is y bar squared. Okay? So, substitute natin dito ay CG plus area y bar squared. So, simplify pa natin. Okay, so from the figure, yung YCP, that is equal to, so from liquid surface, okay, so again, from liquid surface, papunta dun sa center of pressure natin. So that is equal to y bar plus E. Okay? So, yung YCP natin, or YCP, center of pressure, is equal to y bar plus yung distance E. Okay, so equate natin dito. Then this will be equal to, so pag pinag-iwalay natin yan is I moment of inertia about the center of gravity over y bar area, or area y bar. Then plus area y bar squared over, so pagbaliktarin ko na to, no? Area y bar. So pwede na natin i-cancel yung area y bar squared over y bar is y bar. Okay, pero meron tayong may y bar tayo dito, meron tayong y bar sa left side, so pwede natin i-cancel. Okay, so para silang positive, then we can say na yung distance E pala is equal to, okay, so the center of moment of inertia about the center of gravity over area and yung ating y bar. Okay. So yung y bar natin is hanggang doon sa liquid surface na ina-assume natin na 0 yung gauge pressure. Okay? So ina-assume natin na 0 yung gauge pressure. So paano kung may pressure pala dito sa taas? So ma-discuss natin yun dun sa mga examples natin. Okay? So yan yung ating derivation. So again, force F is equal to unit weight h bar, yung depth ng centroid ng area times the area, or yung pressure sa center of gravity or center of area natin times the area. So that is yung force. YCP is Y again from liquid surface hanggang sa center of pressure is moment of inertia from the surface, about the surface of the liquid, then over area y bar, then yun na nga, no, yung distance E natin is magiging moment of inertia about the center of gravity lang naman, pero over area y bar pa rin. Okay, so siguro I'll stop muna dito para hindi masyadong mahaba yung video. So this will be the derivation of the formulas na gagawin natin. So mahaba rin kasi yung mga examples. So we will stop muna dito, then let's continue with the examples on the other videos.